Hello and welcome to CNC Beginner's Guide. My name is Stephen Thompson, and in this video we are going to wrap up Project 2 by creating machining notes, setup sheets, and post-processing G-code for Setup 1 and Setup 2 for Project 2 to run on a CNC machine. So let's get started. Okay, so at the end of the last video, we finished all the toolpaths for setup for Project 2, Setup 1 and Setup 2 here. And now, let's start by working on our machining notes. So the machining notes are kind of a list of really important bits of information that we're going to want to pass on to whoever is going to machine this thing. Maybe that's going to be us later, or maybe that's going to be somebody else. But either way, machining notes are really important. So to do that, I'm going to right click Setup 1 and say Edit Notes at the bottom here. And I'm going to make the notes a little bit bigger, and we can start writing notes. Okay, so you can write anything in here that you want, that you think is important for the machinist to know. I'm going to start with using G54 for work coordinate system, WCS. And I'm also going to say WCS is at top center of stock. I'm also going to say all speeds and feeds are for aluminum. Okay, the next thing that I'm going to write here is something we have to figure out, which is what we did in Project 1, is the minimum part stickout. So I'm going to write minimum part stickout equals. And now we got to go figure out what that is. So go ahead and click OK. And let's see what minimum part stickout. So the minimum part stickout, if you remember from Project 1, is, we can think about it two ways. It is the minimum amount that the stock needs to be sticking out of the vise in order to avoid collisions. It's also the distance below the top of the stock that the lowest tool goes. So what I like to do is to look at this from the side to highlight Setup 1, so I have the stock kind of highlighted. And then I kind of like just hover over these different toolpaths and try and see which one actually goes the lowest. So this one goes pretty low. I'm going to turn it on with the little eyeball here, just to keep it on. And I'm going to keep going. The tap goes a little bit, yeah. Okay. Maybe adaptive, the contour, and the chamfer. So I'm going to take a look at this contour one as well. So really kind of comparing these two. So definitely the drill bit goes lower. However, the drill, we don't need to worry about the drill colliding with the vise as long as we set this up on parallels off of the bottom of the vise. And then we don't have to worry about that colliding. So then, because if we were to base our minimum part stick out on this drill bit, you would have to stick out more than the stock, which is not realistic. So we really are, I'm going to turn that one off then. Deep drilling. And I'm actually, write that note. It's a good note. I'm going to, before minimum part stick out, I'm going to say elevate the stock from the bottom of the vise with parallels. And let's see, we could say that the drill bit, the drilling operation goes below the bottom of the stock. Okay, go and click OK, and we're going to figure out how low that toolpath, that drill goes below the bottom of the stock. So we can see it's going to be this drilling operation here. So I'm going to right click it and say Edit, just so we can look at the Heights tab. it looks like there's two things here. One is drill tip through bottom, so the tip of the drill bit has extended through the bottom of the material, and then another 50 thousandths of an inch. But 50 thousandths of an inch only is doesn't account for the tip of this drill bit. So, we could say, to be safe, it's probably going to, 50 thousandths is from this blue line to this edge here. Double of that is 0.1. I think we could say 0.2. If we leave like 0.25 inch clearance below the bottom, make sure that it's elevated at least 0.25 from the bottom, then we should be okay. So go and click OK. I'm going to go back to machining notes here. I'm going to say operation goes 0.25 inches below the bottom of the stock. Okay, so that'll be good for that one. But for the minimum part stick out, if I click on setup 1 again here, click OK, click on setup 1, we have to figure that out. It's going to be, so it's actually going to be the same calculation that it was for project 1. It's the distance, it's the offset from top plus the model thickness plus the bottom height offset. So let's find out what the top offset is. So I'm going to right click on setup 1 and edit, because we set that in here in the stock tab. The offset is 50 thou from Z. So okay, click OK. And then the model thickness, if I click on the inspect tool and click on the top surface here and the bottom surface there, and I could say, we see 0.625. Okay, keep that in mind. And then the last one is going to be this contour toolpath. I'm going to right click and edit and see that the heights tab, the bottom height offset is negative 20 thousandths of an inch, negative 0.02. Okay, so we got to add all those numbers together. See if I can remember them. Go and click OK. Click on the machining notes button there. Minimum part stick out is, I'm going to write this out, offset from top plus model thickness plus bottom offset equals, offset from top is 0.05 inches plus model thickness 0.625, I believe, plus bottom height offset 0.02 inches equals, okay, let's see, we got 675, 695, 0.695 inches. Is that right? 62. Yeah, 695 inches. Okay, so our minimum part stick out is 0.695 inches. Okay, go and click OK. All right, and I'm going to turn that one off. Last thing I'm going to write, I'm actually going to open my machining notes again. And I'm going to, maybe up here after the first section, I'm going to make another section. I'm going to say, after cutting stock material on saw, like a bandsaw or something, measure actual stock dimensions with calipers, input actual stock size into setup 1, regenerate toolpaths, and post process G-code. Okay. All right, go click OK. And so what I mean by that, we went over this in project 1, but I'm going to go over it again. Right click setup 1 and click edit. If you go to the stock tab, these dimensions here were guesses, right? And if this actually deviates at all, it's going to affect, well, it should affect a lot of these toolpaths. And it will only affect these toolpaths. Toolpaths will only actually do the appropriate motions in the correct places and the appropriate amount of material removal if these are accurate. So let's say that we, cut our piece and it's actually 2.35 inches long, and we click OK. Now we have to actually regenerate all these toolpaths based on the new stock size. So I'm going to right click setup 1 and generate. And now we have a second setup. We have to do that with setup 2 as well. Right click setup 2 and generate. So they've recalculated, and that should be good. So make sure that when you actually cut your stocks, you measure that with calipers, and then you regenerate the toolpaths before you post-process the G-code. Okay, so the other thing we're going to need to do here is we're actually going to need to make machining notes for setup 2. So I'm going to click on the machining notes. I'm actually just going to copy all of them. Copy, click OK, and right click on setup 2 and edit notes. And I'm going to paste them in here. And let's see if these things are still true. Okay, so what do you say? Top one, using G54 for work coordinate system. Yeah, that's still true. Okay. Second one, WCS is a center stock. Yes. All speeds and fees are aluminum. Yes. After cutting stock, measure actual stock size with calipers. That one's still okay. Elevate the stock from the bottom of the vise with parallels. We don't need this one anymore because there's not a drilling operation in this setup. We'll probably elevate it with parallels, but not necessarily. Depends on the size of our vise. Okay, and the last one, minimum parts stick out. Now this is where it gets interesting. I'm going to delete all that because our minimum part stick out is actually going to be different because this is a whole new setup. So we gotta start over and see what it is. So go and click OK. And here's what we do. For setup 2, we take a look at it from the side, and we hover over the different toolpaths and which one goes lower. Well, it looks like they actually both go to the same distance, right? They both go to what is effectively the top of the model now, right? So we have to figure out what that distance is. And the distance is really that from the work corner system origin, the top of the stock here, down to that toolpath. There's no way to just measure that. There's no tool that will just measure it. So we have to kind of calculate it. And what it's going to be, it looks like here, it's going to be different from what we did the first time. So it's going to be our overall stock height, so the Z value for the stock, minus the top offset, minus the model thickness. So let's write that. And the only reason I know that is just because that's what it looks like. There's no formula. Each time, you figure out minimum part stick out, it's going to be slightly different. And in this case, it really depends on the toolpaths and the stock and orientation of things. And it looks like for this one, that's the calculation. But you'll have to figure that out for each one. And it can be kind of tricky. So for here, I'm going to write stock thickness minus top offset minus model thickness. And I'm just going to click OK. I'm going to say equals, and I'm going to click OK. And let's check that out. Let's go to right click setup 1 and edit, and go to stock. So my stock height is 1 inch and my offset is 0.05. Okay, click OK. So I'm going to go back to my and then the other thing I need to know is my model thickness, which is 0.625. Yeah. Okay, so let's go back to setup 2 notes. So stock thickness is 1 minus top offset 0.05 minus model thickness, which is 0.625. And let's see, I'm just going to do that on my calculator. 1 minus 0.05 minus 0.625 is 0.325. Equals 0.325 inches. Okay, so a new minimum part stick out for setup 2. Okay, go ahead and click OK. All right. Okay, so those are our machining notes for setup 1 and setup 2. the next thing that we want to do is we want to make setup sheets. So setup sheets are going to give us all of the kind of relevant information for each setup, in terms of like which tools we're using, what are the tool numbers, what's the stock size, where's the work coordinate system, all the information that a machinist might need to know, including our machine notes at the very beginning. So one thing about that is it's going to take a snapshot of whatever you happen to be looking at. So for the setup 1, I'm like working on the top, so I'm going to kind of get like a little angled view here, and then I'm going to click on the view cube corner, one of these corners, to get a nice isometric view. Okay, and now I right click on setup 1 and say setup sheet, and you can just click select folder, or I think on a Mac it looks a little bit different, and it should open up in a web browser your setup sheet. So it says, program comment from before, setup, and then our machining notes, including our minimum part stickout, all the information about the stock, the tools, number of operations, number of tools, tool numbers, the list of the tools that are machining, and then the order of the operations. One thing I always like to check is my minimum part stickout that we calculated. So this was the 1/2 inch end mill, I believe. So if we go to the 1/2 inch end mill here, we should see a minimum Z. That's the lowest that that tool goes. And it is 0.695, which is what we calculated. Excellent. Okay. The thing we're going to do next is we're actually make a second setup sheet for setup 2. So I'm going to flip this over and get a nice isometric view of the bottom of this part and make sure that the X is pointing in a good direction. That looks great. So I'm going to right click setup 2 and say setup sheet and click through that pop-up. We can see here that we now have setup 2 with our new model thickness, or our new minimum part stickout, and all of our notes. And same thing, an image, all the information, 2 operations. And we could see the minimum Z, negative 0.325 and negative 0.325, which is what we calculated. Okay. So that all looks pretty good. Yeah, those are setup sheets for setup 1 and setup 2. So you have to make a setup sheet for each new setup because, even though it's the same part, it's a very different program. Setup 2 has 2 tool paths with 2 different tools. Setup 1 has, 10 operations with 7 tools, and they're all in different orders. They're totally different. So you need a setup sheet for each one. And the thing that I would recommend is that you print or save a PDF of these ones. So you can do like a Control P or Command P to print and save a PDF of these. These are only going to be accurate if they're current. So it really depends on if you change anything in your program, then you need to update your setup sheets, right? Any major changes or any minor changes really in your program, you also need to update your setup sheets so that they are the most current. Okay, so the last thing that we got to do here is we got to post-process the G-code. So for this, we are going to do the 2 setups separately. Now, the way that you do this depends on the capabilities of your machine. If you have a machine that has a tool changer, you can post-process all of these together, and it will automatically change tools between tool paths. Sometimes if your machine doesn't have a tool changer, you can still do the whole setup together, and then it'll have you manually change tools in between. Sometimes it makes more sense to post-process them separately. So I would have to post-process this first one by itself. I could post-process as long as there doesn't involve a tool change, right? So these 3 tool paths all use the same tool. I could post-process those together. So it really depends on your machine setup. So I'm going to right-click setup 1 here and say post-process. And we have the post-process dialog box. For post, You can look at your recent posts here, or you can choose from the library. We went over this in Project 1, but there's basically the Fusion library where you have all the list of post processors, and really the thing that you need to do is to figure out which machine you're using, which is the correct post processor for that machine. So for, for instance, in the Fusion library, we're gonna be post processing to a Haas machine. All of these, so Haas has all of these different post processors because they make, a bunch of different types of machines, right? So some of them have very different capabilities and they need a different post processor. So you have to know, even if you have a Haas machine, you still need to know, okay, well, what type of Haas machine is it and what post processor does it need in order to make G code that my machine can read. So that's something you got to figure out. You can figure out either from the manufacturer, you can reach out to the Fusion team. So I have some saved in my cloud. So I have, let's see, I have the Haas Next Generation Control. So I just choose this one here and say select. So however you choose it, there's the NGC, or whatever your post processor, it should be in here. Program name number 2001, that's good. I set that up in the setup and the comment. And then it's going to save it someplace, so just make sure you can see it someplace. Or make sure that it's going to save someplace here that you know where it is. I'm going to open NC file in editor so I can see what it looks like, but you don't have to. And then I'm going to change any post properties, any configuration properties in here. So this all has to do with, this post processor, the Haas Next Generation Control post processor, works for a bunch of different types of machines, and they may be set up differently. They may have different capabilities, and this post properties is where you kind of specify what your machine can do, and different things for like different ways you want the G code to run to your machine. So, for instance, I want option stop on, preload tool on. I want to say use G0 and G187 off. These are just kind of things that I found works for the machine that I'm running. And then once you've set all of your post properties, click post, and you have your G code successfully posted. And what that looks like is a .nc file, or depending on the machine you're going to, it might be slightly different. And this is it here. This is your G code. So it starts with project and your name. This is the project comment. And then these are everything in parentheses are comments. So these just like says what the different tools are and their kind of geometries and specifics. And then we start out on the G code. And then we have our first operation, which is the facing operation here. T1, tool 1, M6, change tool. Next line, S1910, spindle 1190 RPMs, M3 clockwise. And then it goes through all the G code. Face, adaptive, all the way through your whole setup one. Okay, we're not going to go over really how to like read G code in this tutorial. We'll have other tutorials where we go over like what G code, more on like kind of the details of what G code is and how it works and what it means. But for now, we're just going to create the NC file, or the G code file, and we can run this on a CNC machine. I'm going to close that out. I'm going to do the same thing for setup 2. Right click setup 2 and post process. And it probably will have saved some information from before, so it already knows the post processor I'm trying to use. File name number, that looks good. Saving it in a good spot. And it's even saved some of the preferences that I set in the last time. And go ahead and click post. And that's these files here. And there's the G code. There's a G code. Okay. Looks good. So these are the files that you're going to take to your machine, and you're going to get them onto your machine. Different machines can do this differently. Some you can connect on a network. Others you have to put it on a thumb drive and transfer it over like that. But that is the G code that you will run on your machine. So that is it for project 2. We've done everything from the setups, all the toolpaths, the simulations, changed all the details for all the toolpaths to make them just right, made our machining notes, made our setup sheets, and post-process G-code. Yep, so that is it for project 2. Go ahead and move on to project 3, and we're going to get into some more, some newer concepts, and we're going to practice CAM programming even more. So I will see you over there at project 3.